So this is basically the third question of CodeChef Starter 119 Division 4 Cookie Day. In this question, there is basically a mother who has n cookie jars with her. Each jar contains a different type of cookie, and there are totally AI cookies in the ith jar. Okay. Now she wants to distribute these cookies among her k children. Okay, and she needs to ensure two different conditions. Basically, each child should receive at least one cookie, and for fairness, every child should also receive equal number of cookies, right? And under these two conditions, we need to find what is the minimum number of wasted cookies. Okay, so basically, after distribution, after making sure these both conditions are true, it's possible that there are some more cookies left in the jar. We just need to make sure that those cookies are as minimum as possible. Okay, and if it's not possible to give out cookies, then we can just simply print -1 instead. Okay. So the constraints of the question, there are total 100 test cases, and n value can be up till 100, and a of I and k value is can be up to 10 to the power 9 as well. Okay. So yeah, let's see how we can solve this question. So let's see this example and understand how we can solve this question. So in this example, we have n value as 4, k value as 7, and the array values are 50, 30, 6, and 100. Okay. Now, how do we find out what are the remaining number of cookies after allocating, let's say, uh, equal number of cookies to every single person? Okay. So let's say we pick up this jar and I allocate equal number of cookies to every single children. What will happen then? Every children will get 7 cookies. 7 into 7 will become 49. Okay. And what will be the remainder? Remainder will be 1, right? So what is happening in this case, right? In this case, we are basically doing 50 modulus 7, right? 50 modulus 7 will basically give us the value of the remaining number of cookies after distributing the cookies among everyone, right? Now, this remainder part is valid only in the case where a of I value is more than or equal to 7, okay? Only when a of I value is more than or equal to 7, we go ahead and find these remainders, okay? Right? But after going through the entire array, if all of the values are less than the k value, in that case, we can simply print -1, right? Because it will go against our first condition that every child must get at least one cookie, right? So if all the if the cookies in every single jar is less than k value, then that's not possible. So in that case, we just say -1, okay? Or one better way to put it is, if the maximum number of cookies out of all the jars is less than the k value, then in that case it's -1. Or else we go ahead and we find the modulus value. Okay. So basically 50 modulus 7, 30 modulus 7, then we have 6 modulus 7. Okay. And this will not be into consideration because 6 value is less than k. Okay. So we don't take this into consideration. Okay. And we have 100 modulus 7, right? Okay. So this will give us 1. This will give us 2. This will not take into consideration at all. Even if this value is smaller, we never take this into consideration because the number of cookies in that jar are less than k. Okay. And when we take this into consideration, it will be 2. Okay. So out of these, what is the minimum value? The minimum value is 1. So in this case, our answer will be 1. Okay. So we are just running a simple loop and we are avoiding all the integers where the value is less than k. And we are just finding the number modulus 7 in every case and picking the minimum out of it as our answer. Okay. So it's just one simple loop. So the time complexity in this case will be O of n. Okay. And space complexity will also be O of n because we need O of n space to take the input array. Or actually, we can reduce the space complexity to O of 1 as well. So we basically don't even need to take the input array. We can just run a loop and keep taking integers and also keep finding the minimum value. So O of 1 space complexity would suffice. We don't even need O of n complexity for space here. Okay. So yeah, this is how we solve the question.